Today we are going to discuss about ideal gas and real gas. We will discuss about the differences between ideal gas and real gas. We know that gases are composed of small particles known as molecules, and these molecules are in continuous random motions colliding with the walls of the container and with each other. When these molecules collide with the walls of the container, they exert pressure. So now let's discuss about what is real gas and what is ideal gas and what are the main differences between these two types of gases. Number first is ideal gas. Ideal gas is a theoretical concept. In reality, there are no ideal gases, but ideal gas is just a theoretical concept, unlike real gases like air, nitrogen, oxygen, and other actual gases are known as real gases. In ideal gas, there are no intermolecular forces, and the molecules can move freely without any force of attraction or repulsion between these molecules. But in real gas, there are intermolecular attraction forces that exist. In ideal gas situation, the volume of the gas particle is considered as negligible, but in real gas, they are finite and cannot be ignored, especially at high pressure. Ideal gas obeys ideal gas law, which is PV is equal to nRT at all temperatures and pressure, but real gases deviates from ideal gas law at low temperature and high pressure. At very low temperature and high pressure, instead of using ideal gas law, which is PV is equal to nRT, van der Waals developed another equation which accounts for the attractive forces between the molecules and the finite size of the gas molecule, and we use van der Waals equation for the solution of real gases. In ideal gas, the collision between the molecules is completely elastic, which means there is no loss of energy before and after the collision with the wall or with one another. But in real gases, the collision is not perfectly elastic. There is some loss of energy because of the intermolecular forces. That's it. Thank you for watching, and do not forget to subscribe EasyEdu for more videos.